What can a tiny meteorite tell us about the formation of the solar system? Let's find out. We know the age of the solar system to an accuracy of about a million years out of 4.568 billion years, or about 0.02%. Our understanding of how and when early protoplanets formed is guided by our understanding of this overall age and the ages of objects like meteorites that we discover from different parts of the solar system. By checking the chemical composition of meteorites and the ratios of various elements in a sample, it's possible to determine where in the solar system they originated. Further analysis can give us a surprisingly accurate age for the meteorite. To understand what this tells us about planet formation, let's take a high-level look at how we think the solar system and other systems like it formed. Our basic model is that a rotating cloud of gas and dust collapses to form a star, and then some while later, after much colliding and accreting of the material in the debris disk left around the star, rocky protoplanets form. These will eventually further collide and accrete to form the terrestrial planets as we know them today. The exact timing of all this has been the subject of recent research advances, and it seems that perhaps the star and the planets actually form at about the same time. However these early stages happen, eventually the material that's accreted into protoplanets heats up and separates into the layers that we see in terrestrial planets, such as the crust and mantle. In the early solar system, there's more water and ice the further out you go, so we had assumed that protoplanets out beyond Jupiter would undergo this differentiation phase a little later than the inner planets, as it takes extra energy to melt all that ice. New research on a meteorite called Northwest Africa 12264 has cast doubt on this model and suggests that actually rocky planets formed at the same time throughout the solar system, including out beyond the orbit of Jupiter. The meteorite was confirmed as being from the outer solar system by its chemical composition, and then analyzing the isotopes of lead present in the sample, its age was determined to be 4.564 billion years, which is exactly the same age we get when we examine samples known to come from the inner solar system. Of course, this is just one data point, so further research will be needed, but it's still an interesting result. The delay between the formation of planets in the inner and outer solar system was originally thought to be around 3 million years. The difference between 3 million years and simultaneous planet formation throughout the solar system may not seem like a big deal. After all, what's a few million years between friends, astronomically speaking? But it could have big implications for our models of not just our own solar system, but for the many other exoplanet systems like it. The paper was published in the journal Communications, Earth and Environment on July the 4th, and it is open access. Please like and subscribe if you enjoyed the video, and I will see you in the next one.